Good morning, all students. Now today we discuss some IMP examples for the CCA examination that conducted on Monday. So first example for the reduction formula. Example number one. Example number one. Example number one. Integration 0 to pi by 4 tan raised to n theta d theta equal to n into in plus 1 plus in minus 1. Now to show that integration 0 to pi by 4 tan raised to n theta d theta equal to n into in minus 1 plus in plus 1 plus in minus 1. Here in plus 1 equal to integration 0 to pi by 4 tan raised to n plus 1 theta d theta and equal to and in minus 1 equal to integration 0 to pi by 4 tan raised to n minus 1 theta d theta. Now solution. Given that in is equal to integration 0 to pi by 4 tan raised to n theta d theta. Now to show that integration 0 to pi by 4 tan raised to n theta d theta equal to n into in plus 1 plus in minus 1. In plus 1 plus in minus 1. Now to consider first we consider in plus 1 equal to integration 0 to pi by 4 tan raised to n plus 1 theta d theta. It can be written as integration 0 to pi by 4 as it is tan raised to n minus 1 theta into tan square theta d theta. Since n plus 1 equal to n minus 1 plus 2. Clear? Also, now we know that tan square theta equal to 1 tan square theta equal to sec square theta minus 1 by using 1 plus tan square theta equal to sec square theta. Put these values of tan square theta in our integral, we get in plus 1 equal to, we get here, note that integration 0 to pi by 4 tan raised to n minus 1 theta tan square theta d theta. Here n minus 1 can be, n plus 1 can be written as n minus 1 plus 2. Also we know that tan square theta equal to sec square theta minus 1 by using 1 plus tan square theta equal to sec square theta. Now put these values of tan square theta in our integral. We get in plus 1 equal to integration 0 to pi by 4 as it is. Tan raised to n minus 1 theta as it is. Now put value of tan square theta is sec square theta minus 1 and d theta. Now multiply by tan raised to n minus 1 theta to the bracket term. We get integration as it is, integration pi by 4 tan raised to n minus 1 theta into sec square theta minus tan raised to n minus 1 theta d theta. Now separate the integral. We get integration 0 to pi by 4 tan raised to n minus 1 theta sec square theta d theta minus integration 0 to pi by 4 tan raised to n minus 1 theta d theta. Here integration 0 to pi by 4 tan raised to n minus 1 theta d theta. This is in minus 1, which implies in plus 1 equal to integration 0 to pi by 4 tan raised to n minus 1 theta sec square theta d theta minus in minus 1. Since in minus 1 equal to integration 0 to pi by 4 tan raised to n minus 1 theta, so tan raised to n minus 1 theta d theta. Clear? In plus 1 implies. Now also since integration f dash of x into f of x raised to n dx equal to f of x raised to n plus 1 upon n plus 1. This is the standard formula for the integration f dash of x into f of x raised to n equal to f of x raised to n plus 1 upon n plus 1. Here note that the integration of tan theta, f of x equal to tan theta. Here f of x equal to tan theta. It implies f dash of x equal to sec square theta. So f of x equal to tan theta, f dash of x equal to sec square theta, and n equal to n minus 1. Therefore, the integration in plus 1 becomes therefore in plus 1 equal to integration integration 0 to pi by 4 tan theta raised to n minus 1 sec square theta d theta. By using above formula, we get integration, we get tan theta raised to n minus 1 plus 1 divided by n plus 1 minus 1. Now put the limit of integration 0 to pi by 4 minus, here minus also in minus 1 minus in minus 1, which is equal to tan theta raised to n divided by n, limit 0 to pi by 4 minus in minus 1, which is equal to, put limit, so upper limit minus lower limit, 1 upon n common tan pi by 4 raised to n minus tan 0 raised to n minus in minus 1, 1 upon n tan pi by 4 raised to n minus tan 0 raised to n minus in minus 1. This is in plus 1, which is equal to 1 upon n tan pi by 4 is 1, that is 1 raised to n minus tan 0 is 0 minus in minus 1, since, which is equal to n 1 upon n minus in minus 1, that is in plus 1 equal to, therefore in plus 1 equal to 1 upon n minus in plus 1. Here in minus 1 is minus in RHS. Now we take in plus 1 plus in minus 1 equal to 1 upon n, where n is divided, so get multiply in LHS, in plus 1 minus plus in minus 1 equal to 1. equal to 1 equal to 1 equal to 1. Their question something is wrong. In question, if this is equal to in, if integration 0 to pi by 4 tan raised to n theta d theta equal to in, then prove that then prove that 1 equal to n into in plus 1 minus plus in minus 1. This is now to prove that. This is the required proof. Hence proof. Hence proof.